this video, we are going to be talking about the first of the special right triangles, which is the 45, 45, 90 triangle. So the reason why it's special is because there is a pattern to the sides and how they all relate to one another. So the hypotenuse is always going to be the square root of 2 times as long as any of the congruent sides, so the legs of the right triangle. So things you need to take notice of is that our sides are always going to be the opposite of our 45s. So the opposite of our 45s here you can see are going to equal our variable of x, and the opposite of your right is going to be your hypotenuse. So that's where you see this x times the square root of 2. So again, each of these x values are the exact same value. So if you know what this is, then you can find the other two by simply plugging them in. So here is the ratio. So it's a 1 to 1 to the square root of 2. So each leg is 1 and the hypotenuse is the square root of 2. So let's look at some examples so you can see this relationship and how quickly you can solve for these sides. So here we have a 45, 45, 90 triangle, and we know it's a 45, 45, 90 because we know two of the sides, one being 45 degrees and the other one being 90, and the interior sum of your triangles are always going to add up to 180. So that's going to be a very important fact for you to remember for this semester, is that the interior angles add up to 180 of triangles. So this 90 plus this 45 plus whatever this must be adds up to 180. So you could easily do 180 minus 90 minus 45 to figure out what this other angle is, but this is obviously a 45, 45, 90. So our legs are going to be the opposite of our 45s. So that means that each of these two sides are going to be the legs of our triangle. So what I'm going to do is I'm going to actually set those legs equal to a variable. And I'll show you why I'm doing that in a second. So what I'm going to set these equal to is actually going to be a cursive x, just because x is something you are kind of used to seeing as your variable. So each of these two things are equal to x. So that means that this one down here, if we follow our pattern, is going to be x times the square root of 2. So all I need to do is just solve for x, and once I know whatever x is, I can then go and plug it into the other equations. So here I notice that I actually have what x equals. X actually equals 4 times the square root of 3. So that means that over here, this also is going to equal 4 times the square root of 3, because again, this is what x equals. So I can just say, hey, this equals 4 times the square root of 3. And down here, I just need to go and plug in that value for x. So we would get, so plugging in the value for x, I'm going to get 4 times the square root of 3 times this square root of 2. So this is just a multiplying radicals together. So all I have to do is multiply the coefficients and multiply the radicands. So my coefficients are 4 and 1, and my radicands are 3 and 2. So this is just 4 times the square root of 6. So looking at the next example, again, I'm going to start this example off by setting each side equal to the variable of x, or the x times the square root of 2. And in this problem, I again know that this is a 45, 45 because these two sides are actually the exact same variable. So they're already equal to x. So that makes this an isosceles triangle. And the only way to make an isosceles triangle with a 90 degrees is for each of these to be 45. So I'm going to start by setting each side. So this is going to equal that cursive x. This one also equals cursive x, and our hypotenuse equals x times the square root of 2. So I don't know what the variable x equals as of right now, but I can solve for this one because this is the only equation that has a number on the left side for me to solve. So I can do that. So I can do that by solving for x. So since x is being multiplied by the square root of 2, all I have to do is go and divide both sides by the square root of 2. So that's going to cancel over there. And here, again, the square root of 2 divided by the square root of 2 is also going to cancel. So that leaves me with x equaling 2. So then I can go and I can substitute this in for all of the other ones. So that means this equals 2. And over here, this also equals 2. So here is the u try for u. So this is also these two variables, x and y, are the same. So this is the variable x. So here is the u try. So again, pause this video and see what the other two sides equal. So you would have gotten the sides to equal 9 root 2 over 2. So remember, if you got 9 over the square root of 2, you just need to rationalize the denominator, and you would have gotten the correct answer. So just rationalize. So again, that is why we started with radicals.